Hello, my name is Dr. Sonja Kolstoe, and I am here to talk to you about how economists use data to value birds and ecosystem services. We'll talk about the different kind of data that economists use to do this, and I want to take a moment and thank the Maryland Ornithological Society for inviting me an invitation to come speak at this year's annual convention. I also need to say that the views expressed within this presentation are my own and not necessarily those of the USDA Forest Service. Any errors in this presentation are my own. I don't think there are any, but just in case. So one of the things I want to share with you before we get too far into the seminar is a bit about my background. So I'm an economist who focuses specifically on valuing environmental goods and services. So my training, I earned my PhD back in 2016, and my dissertation focused on valuing birds to bird watchers using eBird data. So this is where I think a lot about how we can use things like citizen science and other crowdsourced data products to value ecosystem services, especially recreation. After I graduated, I joined the faculty at Salisbury University in the Economics and Finance department with a joint appointment in the Department of Environmental Studies. I've then gone on to become a research economist for the USDA Forest Service, and I am a research economist within the Good Services and Values program at the Pacific Northwest Research Station. This is allowing me to focus more so on the research and especially focusing on the human dimensions of wildlife and outdoor recreation, so I get to keep doing more work looking at valuing birds and bird biodiversity to bird watchers. So I'm really excited to share this work with all of you. I want to start with saying let's go through an overview of what I'll present for the rest of this seminar. I'm going to first explain the mission of the USDA Forest Service, and as well as provide the definition used by the Forest Service and that is given within the 2012 Planning Rule. And then we'll talk about the total economic value of environmental goods and services. This will hopefully help provide context to why the government agencies such as the Forest Service employ economists such as myself to do work within these agencies. You can also see that we're going to go through examples, and we'll talk about, again, different data sources, but also think about the different studies where these have been applied. The USDA Forest Service's mission is as follows: to sustain the health, diversity, and productivity of the nation's forests and grasslands to meet the need of present and future generations. I want to take a moment to draw your attention to the latter half of this mission statement and point out that while it's focused on to sustain the health and diversity and productivity of the nation's forests and grasslands, it specifically actually gives a time frame, right? Present and future. And we're going to see that this is going to be important in the context of valuing environmental goods and services because there is something called bequest value. So stay tuned. So the formal definition within the Forest Service about what are ecosystem services is as follows: benefits of people obtain from ecosystems. There are 4 different categories of ecosystem services. They are as follows: provisioning services. So when we think about things like clean air, clean water, all that actually falls under provisioning services. We also think about energy, fuel, forage, fiber, and minerals. The second category within ecosystem services is regulating services. This is our long-term storage of carbon. So when we're talking about carbon sink potential of our forests and oceans, this is where that comes into play. Climate regulation, water filtration, purification and storage, soil stabilization, flood control, and disease regulation. The third category within ecosystem services is supporting services. So when we think about pollination, seed dispersal, soil formation, and nutrient cycling, all of those are categorized as supporting services. The last category, not least, and I say that because while I'm very biased towards this one because this is where I do my research fits in terms of valuing ecosystem services, is under cultural services. So these include educational, aesthetic, spiritual, and cultural heritage values. It also includes recreational experiences and tourism opportunities. So my work is really focused on the recreational experiences and tourism opportunities as I really look to then value the value of environmental goods and services for the purposes of recreation. And I want to just share a few fun facts with all of you You may not know that 45.1 million people observed birds back in 2016. So this is a factoid from the U.S. Fish and Wildlife Quinquennial Survey that they conduct every 5 years. So the last one that was conducted was in 2016. And they publish information about people that are going fishing, hunting, and wildlife watching. The wildlife watching component was added back in 1991 as they saw the rise in non-consumptive activities. You can see that most people who go bird watching actually do so within a mile of their home. So 86% of the 45.1 million people are really doing so in and around the home. However, more than a third, so 36%, are actually traveling more than a mile from their home to go bird watching. In terms of where people are going bird watching when they're going away from home, we see that most individuals, so 60%, are actually going to public areas, so public lands, for example, to go bird watching. So we can start to see how, again, this is good to know in terms of what are people doing in terms of recreation on public lands. It comes to when people are going away from home for the purpose of bird watching, they are visiting our public lands for the purpose of bird watching. So this is an important, then again, ecosystem service when we think about recreational opportunities to measure. This also becomes important because we understand that anytime we are going to allocate resources, so public dollars, towards anything, we need to think about weighing the benefits and costs. And so this is why we need to value bird biodiversity. We also know that, sadly, since 1970, we've lost about 30% of the 1970, our bird populations have declined by about 3 billion since 1970. So this is information. This is also then a figure from a study published by Rosenberg and al. Back in 2019 in Science. And they used the data to show that these bird populations have been in decline. And so thus, it provides gives us pause, especially as we know that there are actually benefits that we derive from birds. Since this becomes an important role of, this is where economists such as myself have an important role to play in terms of doing these studies to quantify these benefits such that they are considered when making policy decisions. So when we think about the different ecosystem services provided by birds, well, we've already talked about how bird watching is on that list. Again, both at home and away from home. We also want to think about, hey, you know, we like birds because not only are they pretty to look at, they also help control pests. So when we think about insects, right, we also realize that they play an important role in pest control. We also know they're pollinators, right? So when we think about maybe certain species come to mind, hummingbirds, for example, but other as well. We also understand that birds help to disperse seeds. Some bird species are scavengers, and they'll help to cycle nutrients within our ecosystems. So we have these benefits, right? We have these ecosystem services. Now there's that big question of like, well, how do you do it? Well, that's what I'm here to tell you about today, as well as talk about the data that we use to do it. So let's start off by looking at this chart. And I really like this chart because it brings to light that there are different component parts to be considered when we're thinking about the total economic value of any environmental good and service in question. We need to think about how there is use value as well as non-use value. There's also something called option value, which when we think about how to measure it, is actually going to be under non-use value. And so why I want to bring this to your attention is because it can start to help solidify what are these kind of benefits that we're thinking about when it comes to ecosystem services. We understand that there's things that we can literally get in terms of goods. So when we think about timber, right, so we think that as being a product of forest that's then cut down to then build things like homes. We also think about how there's other non-timber products that can be harvested as well. We also have recreational opportunities, so hiking and birding, for example, are just some of the many examples we can think about in terms of recreational activities people participate in when they go to visit public lands or engage in nature. And remember, this doesn't have to be solely on public lands, because after all, right, these are the environmental goods and services are not limited to public lands. We can also think about the role that ecosystems play, right, in terms of their provisioning, regulating, and supportive services. So when we think about indirect use values, many of these fall under this indirect use category. For example, we think about water filtration, preventing soil erosion, flood protection, carbon storage, right? So thinking back to that whole carbon sink. When it comes to these non-use values over here, we can see that it becomes a little bit more complicated, because again, these are things where we're not going to observe any kind of trace evidence of interacting with that environmental good and service, but it doesn't mean we do not value it. We have value that is derived from just the fact that we like knowing we can potentially go there in the future at some future opportunity. We also know that there might be the potential that there could be potential pharmaceutical drugs that could be found from nature in an area. We like knowing that a place exists, so whether we go there or not, and we like knowing that the environmental goods and services will be around for future generations. This part here, the bequest value, right, as well as existence and option, is something I want to draw your attention to, because it in many ways makes me think back to how we think about the USDA forest mission, and how, while you might think, okay, for the present and future generations, it's just being like, oh, well, present through the use value, but it also includes that option use value as well as the existence value. The future generation part definitely gets at the bequest value component when we talk about future generations within that USDA mission. So, okay, so we're going to talk about data. What do I mean by data when it comes to valuing environmental goods and services? Obviously, there's going to be cases where, like, for example, in timber sales, we actually have a price that the timber was sold at, right? So we have that information. When we don't have a market price that's available, there's also ways to then be able to infer the value through the actual or stated choices people make. This is where you might think back to your principles of microeconomics classes, where you probably learned on the first day that economics is, after all, the study of choices. We have to make choices because of scarcity, right? We have limited resources, and so what we choose reveals what we have, what we place the highest value on. And so this is where, by looking at people's choices and the trade-offs they're willing to make, we're going to be able to infer the value of environmental goods and services. So, food for thought. So this chart here is not meant to be intimidating. It is meant to outline how there are many different techniques, and they all serve a purpose, because after all, we need to think about how to measure the different component parts of that total economic value of any good environmental good and service in question. Obviously, as we talked about, there's going to be some cases where we can observe some direct market data, right? So price-based, cost-based, and production-based, where we're going to be able to look directly at market data about what's done. In terms of, we're going to observe market prices and have actual transaction data. There's also going to be the case where we're going to observe people choosing to go to a recreational site. So think about, I don't know, Assateague, right? Or maybe think about Blackwater National Wildlife Refuge. Just some examples. People are spending time and money to go there, and so again, it's a trade-off. So that's the premise underlying the travel cost model. And so using that, you're able to then value, again, the use value component of that environmental good and service or that site for the purpose of that recreation. When it comes to hedonic pricing, we're typically referring to hedonic pricing in terms of looking at the price of homes, and so looking at what makes up the value of local amenities, namely environmental goods and services, as they contribute to the value of a home. And so this is where then they use real estate transaction data to be able to estimate, using regression techniques, to estimate the value of local amenities to include environmental quality in an area to get at those values. We also have cases where we understand that for option, bequest, and existence value, we're not going to be able to observe any engagement with the in question. So that means we're going to use methods that are going to come from survey techniques to be able to understand people's preferences based on how they answer questions. And so what trade-offs they make when they're asked, say, for a ballot measure that may protect land and species for future generations, or that may cover the cost of restoring an area, right? To again, to protect the area and make it viable for others to enjoy in the present, but also in the future. Realize that there's these stated preference techniques can be also used to measure use value. So realize that this is the versatility of stated preference techniques. So data, let's talk about the data. After all, models are cool, but they're even cooler when you have data to actually then look at empirical results. And so there's many different kinds of data sources. We think of there being traditional data sources. We can think of, again, administrative data sources. So when you think of real estate transactions, that is a very viable source of data for people to use. And so using that, again, there's been a lot of hedonic studies that look at valuing local amenities from urban forests, from biodiversity, looking at the impact of wildfires, looking at the cleanup costs, looking at the effects of cleaning up brownfields. So again, this technique and that kind of data set has been used extensively to understand what it means for there to be an environmental improvement, or as well as looking at a change, so for the worse, the degradation in environmental quality. We can also think about using surveys. So some are done by the census. So think about the American Community Survey that rolled out in 2005 that is administered to a random subsample of the US population. The US Census, right, decennial census, is something that's only done every 10 years, but that's the entire population. And so what the American Community Survey does is that it allowed us to shorten the US Census, right? So the census form now, so as of 2010, is much shorter than compared to the 2000s and earlier census forms. The American Community Surveys allows us to then, as researchers, is that it gives us insights to how the population is changing over time with constant snapshots of the population. And so many researchers are very grateful to have that American Community Survey data in their analyses. We also see that, so for example, the Forest Service administers a survey that the National Visitor Use Monitoring Program, and this is where they do on-site visitor counts and surveys to understand visitation to national forests across the United States. And so they do this, and it's a 5-year rotation so that every national forest is sampled every 5 years. We also see that there are specially designed surveys that are designed to answer specific research questions funded by grants. And so you'll also see these kinds of surveys. And this is actually one that I'll talk to you about in just a bit, because I'm going to show you an example from my own work that was funded by a grant. A lot of this data has info on people, but it doesn't have information on the environment. And so GIS data allows us to merge in, using geocoordinates, the environmental data and how it's changing over time. And so this is where GIS data plays a really important role in helping us pair together what's happening on the human side as well as what's happening on the environmental side. And so we've seen a huge explosion of use of GIS data in non-market valuation studies. Right? So non-market valuation, again, refers to the value of environmental goods and services not bought and sold in the marketplace. So this is an example from my own work. It's part of a Delaware Sea Grant, and I am working with my undergrad research assistant, Kelsey Posel, on the economic side, and we're looking to understand how trip behavior will change under sea level rise. And so this is the economic part that we're working on. And one of the things, again, thinking back to the ecosystem services, we have some examples in our lovely figure here, right? Recreation is just one component part of our ecosystem service. However, we realize that sea level rise is going to alter those experiences because it's going to reduce the amount of public lands available for the purpose of recreation. For that purpose, we understand, okay, where are the coastal public lands in Delaware? That is shown to you here in pink. Right, we can see that it's pretty extensive, the amount of coastal public lands in Delaware. It's pretty amazing. However, Delaware is the lowest lying state on average, in terms of average elevation in the United States. This makes them highly susceptible to sea level rise. And so when we apply projections of sea level rise, so in the middle here in blue, you see that that's with 3 feet of sea level rise, and you can see that much of the current coastal public lands would be underwater, and that with 7 feet, it would be completely underwater. So this is where the projections here for sea level rise were out to 2100. However, what we do know is, even though these projections are for the very distant future, is that these opportunities are already being affected by sunny day flooding, also known as nuisance flooding, as this is already sea level rise is actually, the rate of sea level rise has been increasing over the last several decades, and it is predicted to increase over this century. So the data we collect in our survey instrument is TRIPS data for 2019 and 2020. Because after all, we realized that 2020 was a year not like the rest, so we want to be able to understand how trip behavior was affected by the pandemic and the lockdown. And we want to then also understand how they would change their trip behavior based on the amount of area reduction in size of coastal public land. So they were asked about how they changed their trip behavior, whether when coastal public lands were reduced in size of an area by 25%, 50%, and 75% respectively. So this work is ongoing. This is actually part of Kelsey's honor thesis for Salisbury University, part of her undergraduate degree. So I have to say on this project, please stay tuned for future results, but it is a work in progress. So that is just one example of how there can be a special purpose survey that's done for the purpose of getting at a specific research question. This is commonly done, and so there's many different studies. So for example, the Differendorfer and all studies actually looking at valuing monarch butterflies. So again, this is just one thing that you can look at, whereas like the Gascon and all that was recently published in the Journal of Outdoor Recreation and Tourism was looking to understand the economics of the Conservation Reserve Program and the wildlife it supports, right, in South Dakota. So again, so the Conservation Reserve Program is something that's funded by the USDA. And so this is where they want to understand those benefits. So again, coming back to valuing those ecosystem services. So we can see that those studies are going to be things that are typically one-off because they are funded for that purpose. We can see that there are going to be more long-running data sets when there's things like permits. So in the Forest Service, if you've ever been to a wilderness area, you've probably filled out a wilderness permit because that's what you have to do to access that area. And economists have used that data to then look at valuing those wilderness areas to those hikers, and as well as looking at how they've been affected by things like wildfire. So these are things that Hilger and England have looked at, as well as Sonjas and all. And so realize, again, this is kind of an example of more traditional data, but this is also a case where it's going to be available for a longer time series. It's going to be limited, however, to only being for wilderness areas. So when people are hiking in national forest lands, but it's not a wilderness area, we're not going to observe that data necessarily because they don't have to fill out a permit. Again, don't forget to purchase your pass, right, to be able to park in those parking lots. But there's no trace really left then as there is with the wilderness permit. You can also see that we've talked about previously about housing prices. So we've looked at, well, not we have looked at, but we have talked about, we have talked about how we can use real estate transactions to understand the value of local amenities. And this also includes how they're affected by things like wildfires. So this is where the Mueller and all actually is looking specifically at how home prices were affected by both wildfires and flooding, right? So just for to give you an example, we can also start to see that, okay, so there's a lot there. We can see that there's ways to value these different things. So what does non-traditional data sources like citizen science and social media posts bring to bear, and how does it contribute to the literature? Well, one of the things that non-traditional data such as citizen science and social media posts has allowed us to do is trace evidence of people going recreating in areas where data would otherwise not be collected. And so that's been a really neat thing, is that we're able to just see more evidence of people enjoying public lands for the purpose of recreation. And so I have co-authored 2 articles on this to date, as well as have several working papers about valuing birds to bird watchers and understanding how those values are going to be affected by things like climate change. So that's what the 2018 paper is about. And then the Robertson study was actually focusing on valuing waterfowl, so people to bird watchers. It might interest you to know that the article by Ling and al. Was not one focused on recreation, but one focused on understanding the co-benefits to birds from the passage of the Clean Air Act and its subsequent amendments. And so the resulting decrease in pollutants like ozone actually help bird populations and help reduce the amount of decline, so the loss overall of birds, because it helped reduce the amount of pollution that was in the air with the passage of the Clean Air Act and its enforcement. When we look to social media posts, we typically see in this area of the literature that people are looking at estimating recreation benefits from recreation as well as visitation models. And so these are just some examples where, so Fisher and all, they were using social media data and on-site counts to measure these benefits, and then St. Clair and all was using social media data to look at visitor models and patterns in Germany's national parks. So again, this is just something to show you how there's really a wide breadth of work that's being done, and especially in terms of what's being done with crowdsourced data and recreation is actually really taking off, because it's giving us insights to where people go and how they recreate in a way that we really didn't have data previously on. And so that's been really exciting from a researcher perspective. Okay, so while that's really exciting, one thing that always makes researchers, gives them pause, if you will, is thinking about the sampling properties of crowdsourced data, right? So are these samples random samples of the population? Are these samples going to be representative of the preferences of the general population? Well, let's think through this exercise. So if this group of smiley faces represents our population, right? If we were the decennial census, right, we'd be sampling everybody, right? So everyone gets to respond to the survey. If we're the American Community Survey, right, we get a random draw. And right, we understand that this is good statistical properties. Think back to your stats class that, okay, you can make causal inference because, again, you drew a random sample. So the outcome's not going to be correlated with anything about the individuals. However, we have to worry about that with crowdsourced samples because we don't know the selection generating process, the sample selection generating process. And so we need to be concerned about that process because, after all, this is a non-random sample. And so we're going to see that while, again, we can learn a lot, we need to be careful about making inferences without correcting for that sample selection process that's underlying the data generating process in crowdsourced data. And this is something that my co-author, Dr. Trudy Cameron, and I have been working on, and recently we've had an article accepted at Land Economics. This is the first in a series of work where we're looking to understand how to correct for samples of convenience using an auxiliary survey of a representative sample, as well as then the survey, a sample of our eBird members. And so what we're able to do is we're able to model the data generating process, so the sample selection process, by understanding that, well, we have a random sample here, right, here, and we have our eBird members, we know, are some portion here of our bird watchers. So based on the fact that we observe information about how there's an overlap here within our random sample, that we're going to have bird watchers, we're also going to have bird watchers that are eBird members, we're going to be able to use this information to model the selection into being an eBird member. And that's why we need to have that auxiliary sample that's a random sample, so that we can then model the sample selection process and then correct for it within the sample from eBird. And so this becomes then an effort where by doing so, by having this information from this representative sample, we can seek to correct the estimates from the models estimated with crowdsourced data to be reflective, or at least more reflective, of general preferences of the population. And so we wanted to work on answering this kind of important question in the literature, because we understood it was an important hurdle that was going to forever hold back the type of the viability of using crowdsourced data to make inference for public policy purposes. Right, so if the data only remained from the sample of convenience without any corrections to be representative, there was always going to be that underlying concern that any estimates are only valid for that crowdsourced sample, right? It could not be, again, used for the broader population. And so that's really something that we focused on addressing and developing this technique. And so we're really happy that that first paper has been accepted. I've also been working with another set of co-authors to address this question for social media data, and so that stuff is in progress right now, and under review. So that's why we're not talking about it today, because I'm happy to answer more questions, any questions you might have about the in-progress work. But I wanted to share this with you because it's been accepted, and so we're able to show that by utilizing this technique, you're able to address the bias within that sample that you wouldn't otherwise, that would otherwise be an issue in the estimates from the crowdsourced sample. Okay, so we're wrapping up here and getting towards the end, and I wanted to bring us back towards to looking at this figure. We can start to understand that there's a lot of potential that crowdsourced data from citizen science projects to social media gives us an opportunity to understand. We can see that in terms of a lot of the potential is probably most for use value, because obviously when we're seeing people post to eBird or to social media, they're actively using the environmental good in question, and so that those techniques then apply. We can also start to think about using social media as a way to engage with the public, to give them stated preference surveys. And this is something we're seeing more of in the literature as well, from looking to understand the value of viewing bears at Katmai National Park, to understanding what's the willingness to pay for expanded access to a site with limited access, be able to see endangered and threatened species. And so all this kind of work allows us to see that there's a world of opportunity to also estimate the value of the non-use values of things, which was previously something not really thought to be done with crowdsourced data. Again, because my co-author, Dr. Cameron, and I have sought to address the sample selection problem, so we now know what kind of data needs to be collected to be able to use that kind of the crowdsourced data in conjunction with a representative sample to model the sample selection process to be able to estimate those corrections and incorporate them into the model estimated using the data from a crowdsourced data source. This all matters because we know that there's important ecosystem services to be measured. And in some cases, without the crowdsourced data, be it from a citizen science project, right? eBird is one. We can also think about local citizen science projects where they're looking at looking at measuring air quality as well as water quality, right? So there's local groups that work on this to monitor their local air and water quality. So we understand that that can play a large role in terms of what a community is able to do for itself in terms of monitoring its own environmental quality in terms of air and water. We also understand that we think about regulating services, so we understand that that these may not be really easily measured by crowdsourced data, but this is where GIS data is giving us a lot of ability to be able to measure this. We can also think about how sometimes it's about understanding how things that people observe and report to citizen science project can help us understand how to measure supportive services, right? So we think about pollination and seed dispersal. We're thinking about things such as wildlife and biodiversity for the Conservation Reserve Program, right? The USDA funds, right? So understanding that it's a way that we can improve ecosystem health and that we can measure this. Then lastly, the last category that, again, I'm a big fan of, but, I'm biased because, after all, this is literally what I've spent years focusing my research on for the last while. And so recognizing that crowdsourced data really has been a data revolution to be able to understand where people are going for outdoor recreational opportunities. And such as helping land managers better manage these sites because they have a better sense of basically by having more data of thinking about how to manage these sites and looking, especially where the sites are quite popular, right? Then the on-site data matches up quite well to the crowdsourced data. So this is where, again, crowdsourced data has potential. I mean, it's not going to be something that solves all the problems in terms of how to measure all these different ecosystem services, but it's going to provide us insights and ways to be able to value some of these in ways we previously would not have been able to without that additional data. So now I want to conclude and talk about some takeaways that I hope you have from this seminar. The first is that benefits from ecosystem services are really important to measure. After all, just because they're not bought and sold in the marketplace doesn't mean we don't value them. And actually, we reveal every day through our actions that we do value them. And that's just the use value. We also can think about how we like just knowing we can go someplace, right? So outdoor recreational opportunities, and that's option value. We also think about how we like knowing it exists. So maybe you'll never be able to go there, but you like knowing that some pristine area exists. That's existence value. Or perhaps it's both of those plus and or, I don't know, the fact you like knowing it's going to be around for future generations to come. And that's existence value. So this is where we start to realize all these different component parts, use and non-use, become really important to measure so that when we're looking at making decisions from a regulatory perspective, that we're really making a full calculation of the benefits and costs, a comprehensive estimate, and that we have all the information about all the benefits and all the costs. And so that's why it's really important to measure these benefits from ecosystem services, because since they are not, for many of them, they're not bought and sold, they become important to quantify, to be able to then include them in those decisions and in those analyses. I hope it was helpful and insightful when I talked about my own work from what kind of data gets collected for like a special purpose survey to answer a research question. So the Delaware Sea Grant was, I talked about that. I also hope it gives you, makes you more likely to, I don't know, keep contributing to citizen science if you're already an eBird member, or maybe get you to think about maybe signing up and contributing your post to eBird to help them. I also hope it gives you a reason to think about how do people use this data for good. After all, we can learn a lot, and it helps us be better stewards and managers of public lands once we have these comprehensive benefit measures. So with that, there are limitations to these studies, and that's why my co-author, Dr. Cameron, and I sought to develop a method to be able to correct for that sample of convenience problem by developing a method to correct for that sample selection problem, so that from here on out, people know what they need to gather to be able to implement those corrections, to be able to make inferences that are more representative than if you just took the crowdsourced data off the shelf. So it just goes to show that really, over the last decade or so, researchers have learned a lot about how people value and engage with environmental goods and services, especially for the purpose of recreation. And so this is where I can look forward to continue to work in this area, and I hope that this presentation has been of interest to you, and I hope that if you have any questions, you come and talk to me during the Q&A session at the annual convention. So with that, I want to wrap up and say thank you, and say thank you again to the Maryland Ornithological Society for the invitation to give a seminar at this year's annual convention. It's been a pleasure, and I hope that you found this seminar informative and interesting. So with that, have a good one. Take care.